Welcome back, everyone. We have Ucore Rare Metals Inc. It trades on the OTCQX under the symbol UURAF and on the TSXV under the symbol UCU. It's focused on rare and critical metal resources, extraction, benefaction, and separation technologies with the potential for production, growth, and scalability. Please welcome CEO Pat Ryan and CFO Peter Manuel. Nice to see you, gentlemen. Welcome to the conference today.
Hey, great to be here.
All right, the floor is yours.
All right, okay. Thanks for the introduction. And a lot of talk about rare earth these days. The news feed, TV, Newswire, you name it, all this talk about rare earth. It's a very geopolitically charged environment. The stakes are actually quite high. And I know the audience here today, some of you understand what the Ucore business plan has been, where we've been and where we're going. And others perhaps don't even know what rare earths are or where they fit. So we're going to try to hit a bit of a macro message here today about what's happening, where you hear all these different counter strikes and strikes between China and the US in particular, and the business plan that Ucore is involved with. So we'll walk you through our plan. We'll try to explain a little bit of the introductory stuff of what rare earth is, and then how it all fits together at the end of the day. Cautionary notes, which you're all aware of. This slide here is pretty important. Those of you that know about mining, you understand there's extraction and then there's processing. Extraction is the actual mining, and it takes place in all sorts of different spots, South America, Australia, you name it. And then processing typically is something that does not happen at the mine site. And processing is that refining and fine-tuning and getting out the specific elements, the critical minerals that can be used for effective use in downstream products. The key here, though, is that you don't have to control the resource in country in order to control the mineral. You have to actually control the processing. And if you look at the chart here on the right, you'll see that China's done a really good job of controlling the processing. Particularly when we look at energy of the 21st century, you have your nickel, your cobalt, your lithium. You can see the degree of processing control that China has, and that's your energy storage critical minerals. And then rare earth is your energy transition critical minerals, and we'll talk about that in a minute and where they fit. But essentially, again, if you want to control that critical mineral, you control the processing. And China, quite frankly, they've had a very strategic long game. They've gotten this control over many, many years. In the rare earth market, they've been at it for 40 plus years. They have massive scale. They've got commercial deployment. They control 85% of the processing, as you can see on this particular chart here. They control 90% of the downstream, which is the alloy and the metal making, along with the magnet making. And that drives some pretty important technology that's caught in the crosshairs of a pretty serious tariff war right now. It's a geopolitical hot potato. And it is a hot potato because things like heavy rare earth and light rare earth, there are two categories of rare earth, heavy and light. Heavies are not produced at all in the Western world. There are no heavies. And you'll hear the words terbium and dysprosium used. Those are the very expensive per kilogram critical minerals that are heavy rare earth, and they're not processed in the Western world right now. And in order to make a permanent magnet or drive it technologies that are used with rare earth, you need to have that heavy rare earth. So China's made a decision that, hey, we're going to control this. We're going to control this by going after the rare earth market. We've got massive scale. We've had a 40-year head start, and we'll go to work making sure that we actually control and get involved with geopolitics the way you can really push it around. So the Trump administration's, they've got a tough battle ahead of them. There's not a whole lot of mining at all. There's only one new mine's been opened in the US in the past 50 years. There are a couple of other up-and-coming rare earth mines around the world that Ucore is dealing with to get feedstock to bring back to processing and refining. That processing and refining is very small. There's some processing refining happening in Malaysia with Linus Corporation. They're using processing light rare earth in particular. Again, no heavy. You have MP Materials in the US looking to process some light rare earth, but it's very small at this point. To date, what MP Materials has been doing is taking their concentrate and sending it back to China for refining. And once it gets back to China, it never leaves China. It stays there, and it goes into products like electric vehicles and wind energy and all sorts of different products that we'll talk about here in a minute. But again, the key is that the mining and the refining and processing happen in different locations. So it's a very complex chessboard. So when you get into tariff wars and you start putting up reciprocal tariffs against countries where you need that feedstock actually to come back to you in order to be processed to turn into the drivers of the 21st century tech, it gets a little complex. So that's kind of the macro playing field. And China's made a very definitive move here to say, you know what, you're not getting any of this. No one. US, you won't get it. Your allies, Japan and Germany, you will not get it. We will keep it for ourselves, and game on. Let's see what happens. So moving forward here, get my cursor. Where is rare earth used? Permanent magnets primarily. Permanent magnets are the most efficient means of taking electrical energy and converting it into mechanical energy. And we look at the uses out there. You have electric vehicles on the far left. 2 out of 3 electric vehicles in the world, by the way, are made in China. BYD is a huge producer of electric vehicles. These tariffs that are up to stop the influx of electric vehicles from BYD coming into the U.S. market, it's only going to last so long. They can sell a vehicle at $21,000 to $25,000 US, whereas an average EV in America right now, apart from all the tariffs that are in place that are causing parts of the automobile to be that much more expensive, is somewhere near to $55,000 to $60,000 US. So even at 100% tariff on a $21,000 vehicle, it's a cheaper inlay to bring that BYD product in. Wind energy used to grow by 400% by 2030. There are 2 tons of rare earth permanent magnets that go in every Haliade X offshore wind turbine that's made by General Electric. Robotics will actually be the largest user of rare earth permanent magnets by 2030. And that's for everything from shipping logistics. You see all these commercials with things whipping around an Amazon warehouse. And that's driven by permanent magnets that make all these things work. Humanoid robots, manufacturing. We talk about bringing manufacturing back to the U.S. When you bring manufacturing back to the U.S., a lot of it's just going to be technology that drives. It's going to be robotic driven. There'll be some people, jobs that are created, but a lot of it will be very robotic. And then national security, that's the big one. National security, 950 pounds of rare earth elements that go into an F-35 fighter. Your drones, your missiles, your night vision goggles, your sonar systems, all of it is driven by rare earth. And all of it's controlled by China because they in particular control the heavy rare earth side of the equation. And the warnings were there. The West, in typical fashion, actually took all their inventions and just sent them off to China over 50 years ago and said, hey, let's just make these. And low cost was the winner. And when it came to critical minerals, the sentiment was, well, they'll always be there. But that's not the case. It's not like a phone app where you just update it every week. And now that the tariff war has really elevated, this long game that China's been playing has resulted in a very dire and gotta move quick situation for the US, for North America, and for the Western world, for the European economy as well, because those critical minerals are not there, rare earth in particular. And just to frame up the news flow that's been happening, in March 2020, March 20th, executive order out of the Trump administration, they indicated that they were going to prioritize separation processing projects, and IBAS would be responsible for that. Under the Department of Defense, by the way, there are 2 categories. There's the DPA and there's the IBAS. Ucore has been working with the IBAS section of the US DoD for a couple of years now. And that particular group's been given the mandate to find mineral processing priority projects. DPA has been given the mandate to look at smooth lining and fast tracking mineral projects and getting them to market quicker, getting through some of the hurdles and the permits. Instead of taking 10 to 12 to 15 years to open up a mine in North America, try to get it down to 5. Much the way an automobile used to take 7 or 8 years to bring to market, or maybe not quite that long. Back in the 50s it did, but 5, 6 years to bring to market. They can bring an automobile to market now in 2 or 3. You need to do that with a mine. So when 20% tariffs were in place around April 4th, the People's Republic struck out and said, you know what? We're going to put export restriction bans on 7 critical rare earth minerals, and there are 17 total of them. but they precisely picked 7 of them, and they were very laser focused on their strategic approach here. They picked dysprosium and terbium, their heavy rare earth, knowing that the West did not have any heavy rare earth opportunity. They picked samarium because samarium is used in samarium cobalt magnets that the DoD uses because it works at very, very high temperatures, and it's very coercive. And when radiation is involved, these samarium cobalt magnets work very well in a fighter jet, for example. But there wasn't a whole lot of clarity on what these export restrictions were. And then the tariff battle went back and forth. I think it went from 85% to 125%, and then eventually 145%. When it got to 145%, on April 13th, China came back and said, okay, we're going to yank some critical bolts out here of the supply chain. No one's getting any of the rare earth material. There's not an export restriction and export overview mandate. We're actually just stopping it, suspending it completely. These 7 rare earths that we picked, they will be banned completely. They also, with that, they had a long list of U.S. companies that China is not allowed to interact with, in particular on the defense side. So those cards were played. And then just last night, April 15th, and it's not in the slide deck here because we had to submit our slide deck before the day closed yesterday. But late last night, Trump administration moved another executive order, and that particular executive order talks about doing a complete review by the Department of Commerce to understand, so what is the total demand of these critical minerals, rare earth included? What are the domestic opportunities? Where do we have to fund and move forward and look at moving quickly to get the job done? What's the foreign manipulation look like? Because there is a lot of foreign manipulation. Any day of the week, China, because they control the complete supply chain, they can move the margin from this week. The margin will be left in the permanent magnet. Next week, they'll pull it out of the mining. And the week after, they'll pull it out of the refining and separating. So it's all a game of manipulation, which is really a difficult and not a fair playing field. So the West has developed its own pricing, its processing, and the Department of Commerce has been charged with putting all that together. So where does Ucore fit in the supply chain? This is the typical rare earth supply chain, and some of you, that have been around the industry, you know this. But that center section right in the middle, that's where Ucore is. That's the processing and refining, and that's the part that is critical. That's the one that actually, if you want to take control or get control back, you've got to have that center section taken care of. You enter the market there in the center section. And that's where Ucore is. We're taking our technology that we'll talk about here in a minute, and we're using a self-use approach, and we're using a joint venture approach to be able to develop that particular section of the market. That's critical. That's what has to be done. There's not refining. There's not processing. It's not a tolling operation. It's a buy the concentrate, produce the concentrate into the refined usable oxide, and sell it downstream to the users on the far right. And the far right, you've got players like General Electric, General Motors, Tesla, robotic people, artificial intelligence people, you name it. On the far left, those are your up-and-coming mines, and they're developing. The developing mines are in Africa, they're in South America, they're in Australia, they're in the Far East, not China, and they become the inputs for the refining in the middle. The key here is that when you open a mine takes 10, 12 years to get on board. When you bring a refining processing facility on board, that center section where Ucore is, you're talking about months, not years, but months. And so it's a real advantage to get that portion of the supply chain up and running. That's where we are. Technology, the technology has always been the differentiator between the West and China in particular. The innovation of the West has been key. Innovation has always won its way forward. Back in 2019, Ucore realized, because we have a property in Alaska that's a heavy rare earth resource, we realized that if we developed that particular resource and brought it to market, all we could do with our concentrate is send it back to China for refining, because there is no refining and separating here in the Western world. So we had to find the best tech that we could possibly find in order to bring this on board and make it possible. We scoured the globe in the Western world. We look at all kinds of different nanotech and high pressure, high heat processes, everything we could put our hands on. We landed on a tech that was actually quite encouraging. It was called Rapid SX. And it was based on the same chemistry of solvent extraction. Solvent extraction is the only process used in the world today to separate out rare earth oxides. It's used in China, and it's massive scales of mixers and settlers. They're football fields in size. And what we liked about this technology that we found is it used far less reagents and chemicals. It deployed it through a computerized column system. The column system occupied 1/3 of the floor space of a mixer settler plant. You could turn it on, you could turn it off. You could do a lot of things with the technology that is really Western innovation. We thought, if you're going to take on this market and this massive scale that China has, let's buy the company Innovation Metals Corp and let's develop that technology. So we've done that. We bought the company in May of 2020. We spent about $10 million getting our technology ready for prime time. It's a pressurized system, meaning instead of an open system like solvent extraction, it's pressurized, which is part of the reason why you're using less chemicals and why you can turn the system off and on. And that turning off and on is very key, because when you look at some of the restricted critical REs that have been introduced just recently by China, if you were trying to produce terbium or dysprosium, set up a plant to do that, it might cost you $300 million. And in order to get that plant up and running, you would have to run it for months on end to try to get it dialed in, tuned in. If something happened, the power went out, it would take forever again to get it dialed in and reset in order to go. With our plant, we're actually running heavy rare earth right now in the Western world. We're running in this commercial demo plant. It's about the size of two tennis courts, and it works with essentially 2 people. It's all PLCs, 600 sensors, completely computerized, and you can reconfigure all the stages to be able to use different feedstocks. It is the smart approach to innovating and running rare earths in the Western world. It's modular, scalable. We can click together like a train, like Lego blocks. We can build 1 line, 2 lines, 3 lines, and not shut the first one down. Some of the other attributes, you can see a little clearer picture here of the system. It's 16 feet high. Those columns are about 16 feet high. And again, the size of 2 tennis courts. We've run 4,000 plus hours on the system right now. We're running heavy rare earth currently. We've got feedstocks from all over the world that we've been testing and running, not China, of course, but outside of China. It runs 3 to 7 times quicker on an OPEX. Our CapEx is much reduced because it's using much less footprint, less chemicals, less reagents going to the OPEX side of it. We can turn it on, we can turn it off, and it's very ESG compliant because it's completely enclosed. When you walk into a solvent extraction plant in China, the first thing you notice, there's all kinds of fumes, and it feels corrosive, and it's not quite as clean as you would expect. When you walk into our plant in Kingston, Ontario, Canada, which is where this plant is, the first thing you notice, there are no fumes in the air. And there are just a couple of people that are running with PLCs that are gathering up data from sensors and going into a central control board. And that central control board, with a machine learning type approach, is adjusting pumps and valves and pH levels throughout the system to be able to produce and refine the rare earth oxides. Really smart engineering. And you want to build a substantial commercial demonstration plant because you've got to deploy it on a commercial nature. I've walked into plants, our team has walked into plants as we were investigating technology that could be possibly used for rare earth deployment. And essentially, to be a little sarcastic, you'll see something the size of a desk with a couple of Bunsen burners and some duct tape, and there's no way in heck that you're going to be able to make that deploy and go to market. We built something very substantial because you've got to do it right. My background's actually automotive. I started a tier 1 automotive company when I was 30 years old. I understand the nature of building commercial plants and making sure that you're dialed in when you go to full-scale commercial deployment. You've got to be flexible. You've got to be flexible in order to address emerging industry needs. With IBAS that I mentioned, IBAS wants to make sure the defense system is very much in good form, but they also want to make sure that the emerging industries are in good form. By that, I mean artificial intelligence, robotics, semiconductors, autonomous driving, green energy from wind to solar, all those industries they want to take care of. So the need to have a tech that does it and does it very effectively is key. The industries that we're talking about here, AI and robotics together, artificial intelligence right now is $240 billion a year. By the end of the decade, it'll be $800 billion. Semiconductors will be over $1 trillion by the end of the industry. We hear the Trump administration talk about semiconductor manufacturing from Taiwan that invested $100 billion in Arizona to add to their current investment. But you know what? They're not going to make any semiconductors unless we get the rare earth side of this sorted out, because the etching tools and whatnot to go into making semiconductors require rare earth. Every industry you see there requires rare earth. When you make an investment in Ucore, you're investing in all those industries. So where does it go from commercial demonstration? Well, it goes to full-scale deployment. And this plant that you see here, this building, Ucore acquired back in January of this year. And that's where we will copy and paste our tech. The column-based technology has all been engineered. The process flow sheets have been developed. We'll be copy and pasting and putting our technology in this particular building. We'll call it plant number 1. It's in Alexandria, Louisiana. It's away from the coast. We worked with the state of Louisiana to find a number of different brownfield buildings that we investigated. I think we had upwards of 18 buildings that we went and visited. This one happens to be on an ex-Air Force base. And it's in the center of the state. It's got a good technical school. It's got a good workforce. It's got good power. It's got all the needs that you'd want to have for a particular, essentially hyped up chemical plant with column-based technology. A lot of chemical plants in Louisiana. One key about this particular base that it's on, ex-military base, it's in a foreign trade zone. There are a handful of foreign trade zones in the U.S. And a foreign trade zone is actually an area where you can take outputs from outside the country, bring them in and process and make rare earth oxides in this case, and export back out to markets like Japan or South Korea, which is where your metal and alloy magnet making resides today, or Europe. And there's no tax consequence. So the tariff battle that goes on, this is a tariff-free zone, which when we went looking for this particular building, the fact that it was a foreign trade zone didn't really occur to us at the time because this is a couple of years ago as we were looking, but today it sure makes a heck of a difference. So imagine we're copy and pasting a growth plan into this building. We're going to start with 7 Rapid SX machines, as we call them, and that will allow for 2,500 tons of rare earth oxide production. They'll add another 7 and another 7. By the time you're done, it'll be 7,500 tons per annum of light and heavy rare earth production. That essentially takes 16,000 tons of rare earth concentrate that will go through this plant, and that's plant number 1. Plant number 2 will be in Canada. Plant number 3, probably a joint ventured opportunity. We have people we're working with in Brazil, Australia, Africa possibly, and back in Canada, opportunities there as well. So we'll look at plant number 2 being in one of those zones. But this is where we'll copy and paste and deploy our technology. Government support. You know, the U.S. Department of Defense stepped up a couple of years ago under what they call an OTA, other transaction agreement. They offered up $4 million. That $4 million US was to just run countless hours of our tech. They wanted to find technology that could beat the solvent extraction of China, and they wanted to make sure it was deployed in a very effective way and got to commercial deployment eventually. The $4 million, we're getting to the end of that program now. About a month from now, that program will be done. A white paper will be coming out, by the way, with all the findings that we'll share with our shareholders, and you'll be able to see all the advantages of the tech in very consumable language. And from there, it's an OTA, which means another $10 million that's being discussed right now with IBAS. I can't say a whole lot about it other than it's another $10 million, and that $10 million will go towards commercial deployment. It'll go towards further engineering workup. It'll go towards 1 new production processing line in Louisiana. When the U.S. program ends, there's a $4.3 million Government of Canada program that kicks in. That's to run light rare earth. And again, just run countless hours, gather your tech data, and let's move forward from there. Then, of course, the state of Louisiana, they came forward with a $15 million package, and they said, hey, all the tax incentives, everything, we want you in our state. And we investigated, by the way, Texas, we looked at Mississippi, Louisiana, loved the chemical trade, loved where we landed in the center of the state, liked the workforce, the tech schools, liked all the rail access in, the highway access in, liked the round trip ability to come from the port of New Orleans. So materials coming from out of country, from Brazil, Australia, Africa, come into the port. We can truck them to our plant in central Louisiana and go on from there. Where does the feedstock come from? We've been, one of our team members has been in the rare earth industry for some 20 years now. And we've been looking all over the world. And we currently have a couple of feedstocks out of Australia that have really good promise to make their way into the Louisiana facility. We have 2 in Africa that are very good potential. We have 2 in South America, and we have 2 in the Far East, which would be, not China, but in Vietnam and those areas. And we've actually been to the mine sites, and we've talked to the people, and we're working out long-term arrangements to bring that feedstock in. And again, it's not a tolling arrangement, but it's a buy the feedstock, process the feedstock, supply it downstream to customers. And we've got some 21 different targets that we've been looking at. There are probably 3 of them that really apply to the launch of the Louisiana facility. And I should have mentioned, by the way, the Louisiana facility, when we look at those 7 lines for the first phase, that's a $65 million US price tag, as opposed to something that's more like $300 million US for a solvent extraction plant. But we can start with one line, then two, and then three. And we're actually looking at that right now. With all the geopolitical pressure, IBAS has said to us on two fronts, hey, if a real emergency hits here, what product could you make in Kingston? Could you actually make some product in Kingston? And we can. We can make samarium used in samarium cobalt magnets for the DoD. We can make gadolinium used in nuclear reactors. We can make heavy rare earth. We're making it now, not in large quantities, but enough to feed some of the defense contractors or perhaps some of the emerging industries that are out there. So that's very key. And the second thing they asked was, you've got a plan to be up and running with the first phase of your production by mid-2026. If we want to accelerate that and get that first line up and running, how quick can you do it? And based on the recent second attack from China with their, you'll get no material at all. We did a lot of work this past weekend to come up with those answers. And the DoD has been highly encouraged by what we propose as a first line that could be put in place by the end of 25 if push really came to shove. And we've got the engineering team that's been working together for a couple of years now, and we think we can make that happen. And we can make three lines happen in Louisiana for somewhere around $38 million US. Again, unheard of, but because of the technology, it allows that to happen. Time is now to establish this westernward processing, refining. I think we've talked about a lot of the rest of it. The Secretary of the Interior has essentially said, let's get this job done. The executive order yesterday said, let's get this done. Let's size up the market. Let's go. And some near-term drivers that we can talk about here just quickly. The Trump executive order, IBAS and its activity, the additional 10 million and what might come of a further investment to be able to deploy quicker because of the state that we're in. The visitors have come to our plant. We've had 26 visitors come to the Kingston plant in 2024. Feedstock people, off-takers, government people, and all of them looking to integrate with the company, either in an off-take arrangement. Some are strategic equity in nature. And we'll have samples that we'll announce going to those customers. And that's in the coming weeks that we'll be announcing some of that. We'll have arrangements with people in Japan and South Korea that we'll be announcing in the months ahead. We'll have different advancements that we'll share, white paper based on the technology development. We'll have a feasibility study that will show the clear path, which was worked out now on an 18-month plan with all the bills of materials and the cash flow month by month to get to where we need to be. And finally, the friendly Western feedstock. Went a little longer than 20 minutes, but we'll try to take a question or two if we'd like.
All right, great presentation. Thank you so much. Yeah, so you are a Canadian company, but you're working with the DoD in the US. So does this put you in a favorable position relative to the recent executive order on critical mineral production?
Yeah, that's a good question. As much as we've had this standoff between Canada and the US, when it comes to critical minerals in the Western world, the two countries must absolutely work together. And we've been, in Washington meeting with different senators and people with the DoD and the IBAS folks for at least 5 years now. And they've understand who we are as a company, first as a mining company, then as we pivoted very strongly to a technology company now with our tech evolution, refining and processing, right place, right time. We've been dealing with IBAS for a couple of years, and they are highly encouraged, really good professional team. And I must say, when you're dealing with the DoD and IBAS and DPA, there's no politics. It's just get the job done. So yeah, Canadian company working with the people that are behind the scenes in the US. It's not political in nature. It's let's get the job done together, and we're in a very favorable position.
And with that said, from a national defense standpoint, how serious do you think the trade war with China is?
Well, some of you know the story of the Silk Road, right? The Silk Road is a story of 1,000 years where they tried to protect the secrecy of silk and become the one, provider of silk to the world. China has been focused on critical minerals. They have ongoing 5-year plans. They have a 25-year plan that they put together. they're long game in their approach. They've been looking at critical minerals and the way to make this happen and take control of the 21st century. And by the way, refining and processing critical minerals in the 21st century is like the oil refining that the Rockefellers invested back in the 20th century. This is the new oil refining. This is where you want to be with critical minerals. China's dead serious about having control of this. They know that the emerging industries depend upon it, and they're trying to shut that door quickly. The US, the Western world, has to move quickly. It's serious. It's very serious. All the discussions we're having are very serious, and we're doing everything we can to take the tech that we've invested in to make it available for deployment. We're here, we're quick, we're first mover, we're processing heavy rare earth now. China's serious, but so are we. Innovation's always won in the West. We intend to win.
Well, wonderful. Thank you. Very important work you guys are doing. We appreciate you being on the conference. We have a lot more questions for you. We're out of time. We'll send you these questions so you can answer our viewers on your own time. But please come back. Important topic that we're discussing here. Thank you, gentlemen.
Thanks very much.
Thanks, Ken.
All right, everyone. We'll be right back.